Hello students. So in today's video, we are going to look at some examples on how we can solve simple linear equation, right? Using algebra. So example 1, okay, what we have here is we have 3a minus 4 equals to a. And when the question says solve, what they really want us to do is to find the value of the unknown. And in this case, it will be a. So how do we go about doing this? The important thing to remember that when we are dealing with equations is that whatever is on the left hand side and the right hand side, they must remain balanced in terms of their values. So whatever operation we do on the left hand side, we have to do the same thing on the right hand side. So in this case, how we're going to go about doing this is that we are going to subtract a on both sides, right? So if I have 3a minus 4, and then we have a on this side, what I'm going to do is I'm going to subtract a here and subtract a on this side. And the end result is that I'm going to get 2a here minus 4 equals to 0. And I'm going to repeat the process this time round with the 4, right? So I'm going to have 2a minus 4. But this time round, I'm going to remove the negative 4. And the way to do it is to actually add a 4. So on the right hand side, the same situation happened. I have 0 and I'm going to add 4. And the result will be 2a is equals to 4. Therefore, a is equals to 2. Right? So because 2 times 2 give me 4. So that's the basic idea behind the solving of algebra, linear equations. Okay. So how about the next scenario? Okay, what happens if we have some fractions? Well, the idea behind is still the same. Whatever we do on the left hand side, we'll do it on the right hand side. So in this case, I'm going to begin by writing it in this form, right? I have a over 3 minus a over 4 equals to 2. Now, there's a subtraction of fractions. So what we're going to do is we're going to make the denominator the common multiple of 3 and 4. In this case, 12. So I will end up with 12. That will be 4a minus 3a is equals to 2. Right? So that will give us a over 12 is equals to 2. Now, to get a on its own on the left hand side, I'm going to multiply both sides by 12. So left hand side times 12 give me a, right hand side times 12 give me 24. Next example, example C. Example C, there are a couple of ways to do this, right? One of the ways to do it is to multiply both sides by a, which will give me 18 equals to 3a. Right? So that means that 3a is equals to 18. Therefore, a is 18 divided by 3, which will be 6. Alternatively, we can also, right, work it out in this manner. We have 18 over a is equals to 3 over 1. That means that a over 18 is actually 1 over 3. Therefore, a is 18 over 3, which will result in 6. So both methods are fine. It's our own personal preference as long as you understand the concept of keeping the balance and the value the same on the left hand side and the right hand side. Right? Okay, moving on to the next example. Example D. This is what we can do. Right? This time round with some decimal is still the same idea. So we have 1.5x. I'm going to add 1 to the left hand side and add 1 to the right hand side. So this is the situation. And then we have 5 divided by 1.5. And that will give me the value of 3 1/3. Okay, we are allowed to use calculator here to check our solution. Now, so we have been looking at linear equation. What happens if it's something like this? This is actually a quadratic. Okay, just to show you that what we can do when we are dealing with quadratic. Again, there are two ways to actually go about doing this, right? We have a situation where the x in this case is going to be positive or negative value of 81, which gives us positive 9 or negative 9. Alternatively, okay, we could also do something like this. X squared minus 81 is equals to 0. So x squared minus 9 squared is equals to 0. That means x plus 9, x minus 9 is equals to 0. Now, what it means is that x plus 9 is 0 or x minus 9 is 0, because when we have the product of two factors and it's 0, either one of it must be 0, right? So x equals to negative 9 or x equals to positive 9, right? So this is just to give you an awareness. We will deal with more quadratic examples in the future. Let's move on to the next section. So next section is classwork. So you're supposed to try them up yourself. So my recommendation is press the pause button now, and then you try the questions. After you have done it, you can unpause it and we can compare answers. Right? So go ahead, press the pause button. And we are back. I hope you have actually tried the questions. Now let us compare our solution. So what can we do over here? In the first example, okay, we can just add 1 on both sides. So I have 3a, and on this side is 15. How do I get 15? Well, 14 plus 1, right? So from here, a is actually equals to 5. Now, going on to the next one. How about this situation? Well, in this situation, we can do the same thing. We have negative 4y equals to, we subtract 4 on both sides, so this will be negative 24. So y is going to be equals to negative 24 divided by negative 4. So y is equals to positive 6. Right? Moving on. You have another scenario. This time round, there's a let's get rid of the 12. Why not? Let's begin there. So this will be equals to 7 minus 3b minus 12. And then we add 3b on both sides. So it's 2b plus 3b equals to 7 minus 12. Which means 5b is equals to negative 5. b is equals to negative 1. Right? So I hope you have been successful so far. Let's go on. We are halfway through all the examples. Now, fractions. What can we do with fractions? Well, my recommendation is to first rewrite it in this form. 3m over 5 plus 1 equals to 3 over 2. That means 3m over 5 is equals to, well, 3 over 2 minus 1 will give us half. Right? And then we can multiply 5 by both sides. So we have 3m equals to 5 over 2. That means m is equals to 5 over 3. When we divide by, 5 over 6. Misspoke. Right? So we just divide by 3 on both sides. So it works for fractions. This is fine. Right? Move on. How about this one, right? So this is a classic case, right? So down here, x, we just need to divide by 27 on both sides, which is fine, right? So x is equals to negative 4. It shouldn't be too difficult. I hope you are having fun with all these practices. And what happens if we have this scenario? Well, we just multiply 5 by both sides, right? So in this case, I'll just have 8 times 5, which gives me 40, right? So it's just a single operation. Now, what happens if we have some decimals, like the next example? Well, it works the same way, right? So we have 2y, and then I'm going to subtract 0.2y on this side, and on this side, I'm going to add 5.4. So it balances out in this manner. That means 1.8y is equals to 5.4. So y is equals to 5.4 divided by 1.8. So y is equals to 3. Right, so I hope you have some success with the classwork. Let's move on. So here is we have a solution, right? that's written out, but there are some errors. And what I'd like you to do is pause the video again, take a look and see if you can identify the errors. And when you're done identifying it, then we will resume. All right, pause. And we're back. So where's the error? Well, first of all, from the first step to the second step, where we get line 1, we realize that we add 2x on the right hand side, but we didn't add 2x on the left hand side. That results in the negative 2x still being here. So that's the first error, right? Is there more than one error? Well, the next one, in line 2, if we have negative 3x plus 2x, this should be a negative x, right? And finally, okay, when we work this one out, the final solution is also incorrect if the x there is negative, right? So it should be the other way around. So this whole thing is wrong. So let's write the correct version. The correct version, we have 11 minus 2x equals to 5 minus 3x, right? So in this case, when I subtract 2x on, add 2x on both sides, this will be 5 minus 3x plus 2x, right? So 11 minus 5 is equals to negative x, right? So from here, we actually have 6 equals to negative x. That means negative x is equals to 6, x equals to negative 6. Okay, that should be the situation. So be aware of all the positive and negative signs, right? Let's move on to the next section. So we have more examples here. Okay, we're going to keep practicing, right? So let's pause the video, give it a try, and when you're ready, you'll unpause it and we'll compare the answers. Okay, we're done. Right, we're back. So how do we handle this? So if we have situation like this, okay, the recommendation is to first of all rewrite this as an improper fraction, right? So we got 25 over 9. And then when we try to find x, remember it includes both the positive and negative versions of 25 over 9, right? So x is equals to 5 over 3 or negative 5 over 3. Okay, example B. Now example B, right, this time round we are only interested in the positive version of this square root, so it's going to be positive 10, right? That means A is going to be 10 over 2, which gives us 5, and that's the only solution. Okay, how about this one, right? So in this situation, what happened is we could multiply a cube on both sides, so I'll end up with 16a cubed. So that means 16a cubed equals to negative 2. A to the power 3 equals to negative 2 over 16. That means a to the power 3 is a negative 1 over 8. So when we cube root this was going to be negative half. So that's one method. Is there an alternative method? Sure there is. So let me show you the alternative method. Okay. Alternatively, we can look at it in this way. This is, let me write it properly. We can visualize this as negative 2 over a to the power 3 equals to 16 over 1. So when it's one fraction equals to another, right? So a to the power 3 over negative 2 is actually equals to 1 over 16. Which means a to the power 3 is actually negative 2 over 16, which results in negative 1 over 8, which means that a is the cube root, so we get negative half. Okay. Similarly, okay, we have another cube example over here. So y to the power 3 in this case is 27, right? So y is going to be cube root of 27. That means y is going to be equal to 3. Right? Okay, let's move on to the next section. Now, what happens when there's brackets? Right? When there's brackets, we can expand the bracket and solve it, or okay, depending on the situation, we could actually move the coefficient of the bracket to the other side of the equation while maintaining balance. So how does this thing works? Okay, so what we can do is over here, we can do this. We can say that okay, 2 minus 0.3x is going to be equal to 1.4 over 2. That means 2 minus 0.3x is equal to 0.7. So negative 0.3x is equal to 0.7 minus 2. That will give us negative 1.3. So x is equals to negative 1.3 over negative 0.3. X is equals to 4 and 1/3. Alternatively, right, we could also just expand the whole thing, right, and get 4 minus 0.6x is equals to 1.4. So negative 0.6x is equals to negative 2.6. How do I get that? 1.4 minus 4. So x is equals to negative 2.6 over negative 0.6, and we should get the same result. Okay, let's look at part B. Part B, this time round, there's lots of parts to this equation. So in this case, it's recommended that we just expand accordingly, just to keep things neat and see where it goes from there, right? So we will expand this. This is 3 plus 6x. Please remember that the negative here gets distributed. Therefore, this is actually minus 5 minus x equals to 10 plus x. Right? So rearranging it, 6x minus x equals to 10 minus 3 plus 5. We have 4x is equals to 12. X is equals to 3. There we go. Okay. So with this, I hope it's successful.